Have you ever heard the terms permutations and combinations and thought, math class? Well, I'm here to tell you they're way simpler and way more relevant than you might think. By the end of this, you're going to start seeing them everywhere.
So to get us started, let's just look at this thing right here. We've all used one. We call it a combination lock. But what if I told you that name is completely wrong? I mean, it's basically a lie. Take a second and think about it. What's actually wrong with calling it that?
You got it, right? If your code is, say, 10, 20, 30, you can't just punch in 30, 20, 10 and expect it to pop open. No way. The order is everything. And when the order matters, you're not dealing with a combination. You're dealing with a permutation. So yeah, you've been using a permutation lock your whole life. And that single idea, does order matter? That is the key to this entire topic.
So here's our game plan. We've already uncovered the great combination lock lie. Next, we're going to look at the fundamental building block for all of this, which are factorials. Then, we'll dive deep into what permutations and combinations really are, solve a few problems, and then wrap up by seeing how this math is actually all around us in the real world.
Okay, first things first. Before we can even start arranging or selecting things, we need a quick way to count all the possibilities we're working with. And for that, we have a super powerful little tool called the factorial.
Now, the notation looks a little weird, I know. It's an exclamation point. When you see a number followed by 1, like n factorial, it just means you multiply that number by every whole number all the way down to 1. So 4 factorial is just 4 times 3 times 2 times 1, which is 24. It's our secret weapon for figuring out the total ways a group of things can be arranged.
All right, let's put that building block to use and talk permutations. Remember our lock? This is the world of passwords, of finishing places in a race, of phone numbers, any situation where the sequence is absolutely critical. A permutation is an arrangement where every single detail matters.
Now, forget about formulas for a second. Let's just use common sense here. Imagine you've got 8 people competing in a race. For the gold medal, there are 8 possible winners, right? Okay? Once someone gets gold, how many people are left for the silver medal? 7. And then for the bronze, 6. You just multiply those numbers together. 8 times 7 times 6, and you get 336. That's it. There are 336 different ways those medals can be handed out. Each one is a unique permutation.
And that is all this fancy-looking formula is doing. It's just a mathematical shortcut for what we just did in our heads. We had 8 total people, and we wanted to arrange 3 of them. The formula is just a clean way to say, take 8 factorial, but only use the first 3 numbers in the multiplication. It gives us 8 times 7 times 6, which we already know is 336. Okay, so if permutations are all about strict arrangements, combinations are, well, they're the laid-back opposite. With combinations, we don't care about the order at all. We just care about who ends up in the final group. Think picking players for a team or toppings for a pizza. Let's go back to our 8 contestants. But this time, instead of fancy gold, silver, and bronze medals, I'm just giving out 3 identical, boring tin cans. Now, does it matter if I give a can to Alice, then Bob, then Charlie, or if I give one to Charlie, then Bob, then Alice? No. The result is exactly the same. Those 3 people get a tin can. All those different orderings are now just redundant copies of the same group.
So the combination formula is just a clever adjustment. We start with the 336 permutations we found earlier, but then we have to get rid of all those redundant arrangements. For any group of 3 people, there are 3 factorial, or 6, ways to arrange them. So we just take our 336 and divide by 6. That leaves us with 56 truly unique groups, or combinations.
Here it is, the ultimate cheat sheet. If you're trying to figure out which one to use, just look for the key words. If the problem talks about arranging, ordering, or lining things up, it's a permutation. If it talks about selecting, choosing, or making a group, it's a combination. That's why picking specific roles like president and VP from 10 people has way more possibilities than just picking a team of 3 from that same group of 10.
All right, enough theory. Let's put these formulas to the test with a couple of classic problems you might run into.
So here's a common one. How many different ways can you arrange the letters of the word leader? It sounds like a straightforward arrangement, so you might think it's a simple permutation. But there's a little trap in there.
See, when we break it down, leader has 6 letters, but the letter E appears twice. That's the catch. If we just did 6 factorial, we'd be counting some arrangements more than once, because if you swap the first E with the second E, you still get the exact same word. It's not a unique arrangement.
To fix this, we use a slightly modified permutation formula. We take the factorial of the total letters, so 6 factorial, and then we divide by the factorial of the count for each repeated letter. Since E shows up twice, we just divide by 2 factorial,
And that gives us our true answer, 360. There are exactly 360 unique ways to arrange the letters in the word leader.
And you know, things can get even more interesting. What if you're arranging people around a circular table? Or what if you have a rule like Sam absolutely refuses to sit next to Susie? To solve that, it's actually pretty clever. You figure out the total number of ways they could sit together, and then you just subtract that number from all the possible arrangements. What you're left with are only the arrangements where Sam and Susie are sitting apart.
Okay, so we've done the theory, we've solved some puzzles, but you're probably wondering, why should I care? Well, it turns out you're using this math all the time, probably without even realizing it.
Think about your password for, well, anything. The reason longer passwords with different characters are stronger is because it creates an astronomical number of possible permutations. The more permutations, the harder it is for someone to guess.
Or take sports. A baseball manager uses permutations to decide the batting order because the sequence is critical to the team's strategy. But when they're just choosing which players get to be on the traveling squad, that's a combination. It doesn't matter if you're picked first or last, you're on the team.
And of course, the lottery. That is a masterclass in combinations. When you pick your numbers, you're hoping to guess one very specific combination out of literally millions of possibilities. That huge number of combinations is exactly why it's so hard to win.
Even planning a trip uses both ideas. Choosing which 5 cities you want to see in Europe, that's a combination. But figuring out the most efficient route to fly between them to save time and money, that's a permutation problem.
So there you have it. From the lock on your gym locker to planning your next vacation, it all comes back to one simple question. Does the order matter? Now that you know the difference, I'll leave you with this. As you go about your day, how many things will you start to see not just as items, but as specific arrangements? And how many will you see as just simple groups? Thanks for watching.